So now that we have learned about spirometry and the volumes and capacities in the lung, we sometimes have to do some calculations in order to determine certain things that we're looking for. So we sometimes have to calculate tidal volume, minute volume, frequency, alveolar ventilation, alveolar minute ventilation, dead space ventilation, and minute dead space ventilation, given the appropriate information. So let's talk about what those individual things are. First, as you learned in a previous video, tidal volume is the amount of air that you can either inhale or exhale during a eupnic cycle. Eupnea means normal breathing. So during a resting normal breath, that is what we call your tidal volume. And it would be listed as a V with a sub T, capital or lowercase. Of course, frequency is the rate of breathing per minute. How many breaths are you taking in a minute? And the minute volume is the amount of air you breathe into or out of your lungs in a minute. So we take the tidal volume times the frequency, and we get minute ventilation. Now the E stands for expiration. And also, again, notice the V with the dot on top of it. That means minute. The V without the dot on top of it just means an individual breath. So we talked about dead space. Anatomic dead space is the amount of air in your conducting airways that does not take place in gas exchange. So when you are breathing in air, the air that is in your trachea, in your bronchi, all the way down to almost right before your alveoli, does not take place in gas exchange. So we call that dead space. And your anatomic dead space does not change. And that is listed as a V sub D. Anatomic dead space is equal to 1 ml per pound of ideal body weight, or 2.2 mLs per kilogram of ideal body weight. So in this class, you would be given the patient's weight, and you would then be able to calculate the dead space, anatomic dead space, based upon that weight. So minute anatomic dead space is the amount of air you breathe in that does not take place in gas exchange in 1 minute. And that is your dead space times your frequency equals your minute dead space volume. Now, one of the other ones we talked about is alveolar ventilation. So this is how much air actually reaches your alveoli and takes place in gas exchange. So we take the tidal volume that you breathe in minus your anatomic dead space, and that gives me your alveolar ventilation. How much of what you're breathing in is actually getting to the alveoli. And of course, we can calculate that for a minute. And so we would take the frequency times the alveolar ventilation, and that will give us the minute alveolar ventilation. The biggest thing you have to remember is, are we calculating for the minute or the individual breath? So when you're looking at the symbols that are being asked, tidal volume is going to be a capital V with a sub T, and that T can be capital or lowercase. Minute volume, or you'll hear us call it minute ventilation, is the V with the dot, sub capital E. Of course, frequency is the rate or breaths per minute and that is a lowercase f. We've already covered some of these things. Alveolar ventilation. How much air is actually getting to the alveoli in a single breath. So that is the V, no dot, with the subcapital A. Of course, alveolar minute ventilation will look almost the same, but it has the dot over the V, which means minute. Dead space ventilation. As you saw in our example, that is the capital V with the sub D. And finally, minute dead space ventilation. That is almost the same, the V with the subcapital D, but it has the dot over the V. So let's look at some calculations. How do we calculate this? Well, let's look at the minute volume. It's the amount of air you breathe into or out of your lungs in a minute. So we know that the equation is frequency times tidal volume equals minute volume. Well, if our patient has a respiratory rate of 8 and a tidal volume of 0.5 liters per breath, which is 500 mLs, if we take 8 times 0.5, our minute volume, or our minute ventilation, is 4 liters per minute. So this patient is breathing 4 liters per minute of gas. But remember, not all of that gas is reaching the alveoli. So let's take a look at their minute anatomic dead space volume. So this is how much air that they're breathing in that doesn't take place in gas exchange in 1 minute. So we have to calculate the dead space and take that times the frequency to get our minute dead space ventilation. So remember, our patient is breathing at a rate of 8 breaths per minute and a tidal volume of 0.5 liters per breath. But we need to know the patient's weight. So the patient weighs 150 pounds. 1 ml per pound means 150 mLs, or 0.15 liters is their anatomic dead space. So if I take my frequency times my dead space, I get 1.2 liters per minute. So of that 4 liters the patient is breathing each minute, 1.2 liters of that is not reaching the alveoli. Or we can express it in mLs. So you will see it done both ways. I don't care which one you do. I don't particularly like dealing with decimal points because it makes it easier to make mistakes. So I tend to use mLs. So how much of the air that this patient is breathing is actually getting into the alveoli and helping with gas exchange? Well, we know that the equation is we take the tidal volume minus the anatomic dead space, and that tells us how much is actually getting to the alveoli per breath. Again, our patient has a respiratory rate of 8, a tidal volume of 0.5 liters per minute, or liters per breath, I'm sorry. And we calculated the dead space in the last equation. So his dead space is 0.15 liters. So if I plug the numbers into the equation, I have 0.5 for my tidal volume minus 0.15 for my anatomic dead space, and that means 0.35 liters or 350 milliliters of each breath is actually making it to the alveoli. And the last example is the minute alveolar ventilation. So how much of the air that you're breathing in, that 4 liters that this patient is breathing, how much of that is actually getting to the alveoli in a minute? So we're going to take the frequency times our alveolar ventilation, and that will give us our minute alveolar ventilation. So we know that his rate is 8 breaths per minute. We know that his alveolar ventilation is 0.35 liters. We just calculated that. So if I take that 8 times 0.35, I get 2.8 liters per minute, or 2,800 mLs. So remember, his total minute ventilation was 4 liters, but only 2.8 liters is actually getting to the alveoli. It's important that you understand this concept because respiratory therapy, we are the experts in breathing. So we have to understand that sometimes we have to make adjustments so we're getting more air or more oxygen to the alveoli to help the patient get better. You will now have a homework assignment in which you will be practicing doing some of these equations. So make sure to look for that in your D2L shell.